Am I audible? Hello? Am I audible? Yeah, okay. So we will start in around 2 minutes. I will wait for 2 minutes more and we will start the session. Yeah, so let's begin. So hello everyone. My name is Rijoy Mukherjee and I am a research scholar at the Department of Computer Science and Engineering, IIT Kharagpur. So I'll be conducting this live session for NPTEL course on computer organization and architecture. Like we will be solving some sample questions which are asked generally in the assignments, and the questions will be similar to what will be asked in the exam. So the session will be interactive. So please feel free to ask any question in the chat regarding the problems, and also the session is being recorded. So this will be available after the class is over. So let's begin. Yeah, so this is the first question. So if the instruction size of a machine is 64-bit long, so which has the byte addressable memory, memory, then to point to the next instruction, the PC value should be incremented by. So it is said that the machine has the instruction size of the machine is 64-bit long, and the memory is byte addressable. Then the PC point to the next instruction by PC. The PC value has been incremented by what value? I cannot increase much the size of the text. That is the maximum I have. So one thing you can do is you can zoom in. At max, you can do that in your browser. So the first question is that instruction size of a machine is 64-bit long. The instruction is machine is byte addressable memory, and the point to the next instruction by the PC value should be incremented by how much? So what happens in a byte addressable memory? So in a byte addressable memory, each byte has a unique address. So each byte has an unique address. So if the instruction are 64-bit long, then the PC value will be incremented by 8 to point to the next instruction to be executed, right? So this is suppose the memory, and the instruction here is 64-bit long. So obviously, and it is byte addressable. So if the program counter is currently pointing to this, so the next program, the program counter after executing this, when this instruction is executed, so it will be pointed to this. So it is 64-bit instruction, so it will be, the PC value will be incremented by PC plus 8. So the correct answer is 8. Any question? So are the questions pre-assigned for the session? If not, can we take gate level question session? Yeah, I mix it up currently. Like sometimes, these are sample questions. So many a time I mix it up. Like previous sessions, if you have like followed, the videos are available. So you will find there are some gate level questions are also being discussed. So, so is this okay? Okay, so I will go to the next problem then. So during fetch operation of instruction, thus the CPU knows what kind of instruction is getting executed, is getting fetched. So what is the process of the instruction like? So the first one is fetch. Next one is decode. Execute. So this is the generally the procedure of like that is for that is followed for instruction, like for the instruction register. So during the fetch operation, we fetch the instruction from the memory address. During the decode, we find out which is the what is the instruction that is being fetched from the memory. So here we find the type of instruction, and then we execute the instruction here. So during the fetch operation, the only thing it does is basically like get the instruction from the memory. So that is the only job it does. The decode phase is the one which where the operation like the CPU understands what is the operation that is being that is the instruction is executing. So the correct answer will be no here, because during the fetch it is not done, it is done during the decode phase. Yeah, this is the IR. The IR does the this job, this decode and execute part. Any question? Yeah, so the question is that during it's a kind of a true false question, like during fetch operation of instruction, does CPU knows what kind of instruction is being executed, is being fetched. So what is the procedure the CPU does? CPU fetches the instruction, so the number one task is fetching the instruction, then it decodes the instruction, and then it executes the instruction. So during the fetch procedure, the only task is to just get the memory, get the instruction from the memory. In the decode phase, it finds out what kind of instruction it is. Also, the what are the operands and the operators that is to be used. And the execute phase, we perform the operation. In a simple way, I can write like this. So if an instruction is add r1 r2, so in this stage the CPU gets to recognize what is the operation that is and what are the operands. So here it gets the CPU understands, okay, it is an add instruction and the operands are r1 and r2, and here it performs the operation using like ALU stuff. Clear? Okay, so I will go to the next question then. So consider the following statement. Program counter holds the address of the memory location containing the next instruction to be executed. Instruction register contains the next instruction to be executed. Which of the following is correct? So the question basically is a tool to understand the difference between an instruction register and a program register, program counter. So both are sort of a register, you can say, but what is a PC? PC contains the address of the next instruction to be executed. And what does IR store? Instruction register. IR stores, so it contains the current instruction being executed. So that is the clear difference between PC and the IR. So if we have instruction move R1 comma R2, that is the current instruction that is being executed, then IR contains this, and suppose this is the memory. So here this instruction is stored. So the IR contains currently this instruction, and PC will point to the next instruction that will be executed, that is the next one. So that is the basic difference between PC and IR. So in this context, option A is the correct answer because the only first statement is correct. So the correct answer is option A. Okay, so it is clear. If you have any doubt, you can ask. So I will go to the next question then. For a single bus architecture, register Y and Z uh, can be used to store immediate values. So, in a single, let's start in a single bus architecture. What happens? The register Y and Z are basically temporary registers, and they cannot be used by instructions explicitly. They are temporary ones. So it can be used to store intermediate values during computation. It can only be stored for the intermediate values. So in a single bus architecture, register Y and Z are temporary registers which cannot be used by instruction explicitly. It can only be to store intermediate values during computation. So so it will be so answer will be A. So I will again repeat. So in a single base architecture, uh, Y and Z are temporary registers which cannot be used explicitly. It can only be used to store the intermediate values during computation. So the statement that is given is is true. Okay, I will go to the next question then. Consider the following set of microoperations for a single bus architecture machine. So these are the timing signals you can see. So at time 1, the like you can call it time 1 or transaction 1. So PC out, MAR in are the two registers, and the control signals are read, select for, add, Z in. Then at transaction 2 or T2, the action is Z out, PC in, Y in, WMFC. Then at T3, it is MDR out, IR in. And then T4, R3 out, Y in, select Y. T5, R4 out, add, Z in. T6, Z out, R3 IN, end. So the micro operation, which of the following, like the micro operation correspond to which of the following instruction? Option A is add Y R4. Option B add R3Y. Option C add R3 R4. Option D move R3 R4. So if you notice, the first three step, T1, T2 and T3, what does it does? So in the first three steps, like the basic operation is loading the instruction address to MAR. So see, you have the PC out and MAR in registers. And the second step is basically incremented the program counter, that this the Z out P in Y in WMFC. T3 is basically loading the instruction register to MDR. Okay, MDR is the memory data register. So IR is the value of MDR is stored in IR in. Now, if you look at T4, T5, and T6, so what does the T4 does? T4 basically the so in T4, Y is loaded with the content of R1, and in the next step in T5, the ALU operation is performed, like the addition. Basically, it adds Y to the content of it adds Y, that is Y in, to the content of R4, and at the step 6 the content of Z is stored to register R3. So T1, T2, T3, T4, T5, T6. T1 does is load instruction to MAR. T2 does is increment the program counter. T3 loads IR from MDR. T4 does is R1 R3 value is stored to Y. T5 does is addition of R4 and Y, and the result is stored in Z. and what T6 does is value of Z is transferred to R3. So basically a addition of R3 and R4 is occurring. So these are the corresponding control signals or timing signals, as you can see. So the correct answer is option C, that is add R3 R4. So I will again repeat. So these are basically timing signals. So if you can see that MAR in, PC out, these are all things. So basically the value. So if you, whenever you see in, that means the value is getting stored there, and out is from value or from that is getting stored, is being transferred. So the first timing signal says that PC value is getting stored in MAR. The second state it says it increments the PC to the next instruction. What T3 does is the MDR value is get stored into IR. T4, what T4 does is it transfers the value of R3 to Y. What T5 does is it adds the value of Y, which is a temporary, which basically is a temporary registers to store intermediate values. So it adds it with R4, and the result is getting stored in Z, another temporary register. Now T6 does, what T6 does is it stores the value of Z to back to R3, because the instruction here is add R3 R4, uh, which basically transforms to R3 plus R4. So the correct answer is option C, add R3 R4. It's kind of a control signal, nothing more. Like if you go through the lectures, it has been like sort of given like what, how it performs, works. It's nothing like too much of a big deal to think about. So so it's basically a control signal, like this read, select for, add, zeta in. These are all sort of control signals. So okay, so we will go to the next question then. Uh, yeah, the slides are also available. So I guess a few weeks back you got a link or uh, message from the NPTEL team regarding where the live sessions are being stored. So if you go to the SWAM website, so you can see there is a live video section over there. So you can click on it, you will see a Google Doc that will appear. So in the Google Doc, you will find the location where these slides are being stored, and also the each week lecture videos that will be accessible to you on YouTube. So those links are there. You can just open the website and search for it. Okay, I will go to the next question then. So consider the following. Consider the following scenario where register Ri is connected through a bus and is connected through a bus. Assume Ri is initially loaded with data X, and in the bus we have data Y. So what will happen when Ri in is equals to 1 is applied. So the options are content of R1 will become Y. Option B, data X will be placed on the bus. Option C, R1 is loaded with Y and the bus will be loaded with X. Option D, the content of R1 and bus will be unchanged. So if you look in this diagram, so it has basically a register and two control signals are RI in and RI out, and the control signals are connected to the bus. So it is being said so that RI, so the currently the data value in RI is X, and that value in the bus is, that is the color green that is shown here in the bus, the value is data Y. So what will happen if Ri in is equals to 1 is applied? So so what will happen? So the control signal Ri in Ri in, so it basically is basically the input control of register Ri. So if Ri in is equals to 1, so that will, so what will happen is the content of Ri will be loaded with the value that is available in the bus. So currently the value that is available in the bus is Y. So when Ri in, the control signal becomes 1, so the content of R1 will become Y. From currently it is Ri, the value stored is X. So when the control, so in becomes 1, so this value will become Y. So the option A is correct. So the option A is correct because the value will R1 value will be Y. Data X will not be placed on the bus. Data X will be placed on the bus when Ri out becomes 1. R1 is loaded with Y and bus will be loaded with X. No, that never happens. It only happens when Ri1 and Ri in and Ri out is both 1. Content of R1 becomes 1. That is one. That is only when the control signals are 0 that is happens. Okay, so this is the A is the correct answer. So this exercise basically shows you how control signal works in a very simplified way. Yeah, so if you have any doubt regarding this question, you can ask. Okay, so I will go to the next question. So the question is a true or false statement. So it says which of the following statement is a true for fetching a word from the memory. The word can be number A. Option A is word can be directly loaded into general purpose registers from the memory. Option B is information to be fetched must be an instruction or operand. Option C is the word can be directly transferred to ALU for further operations, and option D is all of the others. So if you let's work by elimination all. So let's option. What does option A mean? Option A is says that the word which is there in the memory can be directly loaded into general purpose registers like R1, R2, dot dot dot. We can directly uh, push the data into one such part register. So this one is wrong. We all know there are two special registers accessing memory uh, from the for accessing for CPU to access memory. One is MAR and MDR. MAR is memory address register and MDR is memory data register. MER stores the address, so whatever address of this location, and MDR stores whatever stored in this that address. So these are the two special purpose register that is used to fetch a word from the memory. So option A is false. If you go to option B says the information to be fetched must be an instruction and operand. Obviously, so this is true. And if you ask why, is because those are the only two types of uh, values that are stored that in here. One is instruction, another is operand. So either it can be a statement like move R1 R2, that is an instruction, or it can be a value like like suppose a normal value 6000, which is basically a normal operand. Option C, the word can be directly transferred to ALU for further operation. Again, it is no. You have to go through these two registers, MER and MDR, for any sort of operations, be it addition, subtraction, anything. So this is also false. So the correct option is option B. Clear? Or you have any doubt, you can ask. Okay, so let's go to the next question. So consider a single bus system. How many steps will be required to complete the instruction move R1 R2? So, so you try. I will then solve it. Okay. So you try this question. So I have solved like First question again. Yeah, yeah, I will repeat after solving all questions. I always repeat the questions again. So try to solve this. I will see if anyone can guess the answer. Then I will do it. Okay, so I will do it. So the steps to complete the operation will be T1, PC out, MAR in, read, select 4 and schedule. T2, set out, C in, pi in, FC. T3, MDR out, IR in, T4, R2 out, R1 in, and so we solved one question previously, like question number 5, I guess. So it is similar to like that. So what happened? So suppose, okay, let's go back to that question again to understand. So what is happening here? So the first three instructions, T1, T2 and T3, it basically does the same operation, that is load the instruction to MAR, like the program counter to MAR, load the program counter, will be load the program counter to MAR, increment the program counter, load the IR from MDR. So these operations are the basic operations to fetch the instruction into an IR. Same it is done here. Same it is done where T1, T2, T3. It does the same operation. That is fetching the instruction of using MAR MDR from memory. Next, in this step, after this step, it does that decode, fetch, decode, those parts. Now, at T4, it executes the instruction that it has received. That in this case, it is move R1 and R2. So this is basically a move in operation. You do not need something like intermediate temporary register to execute this. So what we do is the R1 in, that is the read instruction. So that is the first one is the R2 out. R2 out means we are moving the value, transferring the value from R2 to R1. So we use the signal R2 out and the R2 in to read the value from R2. So it requires only 4 steps. So 4 is the correct answer, option C. Any doubt? So again, the control signals, remembering the control signal names are not important. The question here asks how many steps are required. 3 steps will always be required because you need to fetch the instruction from the memory to the instruction register. So T1, T2, T3 will always be fixed. Now this instruction does not require any temporary registers. It just is a simple move from R2 to R1. That can be done in only one control signal, R2 out, R1 in. So it will require only 4 steps or timestamps. Clear? Okay, so we will move to the next question. So consider a hardware control unit where each instruction of the machine requires maximum of 50 steps to complete its execution. If the total number of sub instructions are 129, so it requires 50 steps and the number of instructions required is 129. So what should be the size of the step decoder and instruction decoder respectively? Here four options are given. So what is a decoder? So in a decoder, with n select lines can have 2 to the power of n output. Now if you look in this option B and C, it is given 50 cross 1, 129 cross 1, 64 cross 1, 256 cross 1. Are those required? If you look at this, it will always have 2 to the power of n number of outputs. Obviously that is not correct. 2 to the power of 1 is not 50 and 2 to the power of 1 is not 129. Correct? So it will be for 50, what is the nearest 2 power? 64. And for 129, the nearest power of 2, 256, that is 2 to the power of 8, that is 2 to the power of 6. So what will be the correct answer? The correct answer will be 6 cross 64 decoder for steps, and it will be 8 cross 256 for instruction. It's simple, like it has 50. You need to have 50 channels, 50 selection lines. So for how many selection lines that will be required to for 50, it will be 2 to the power 6. That is the nearest multiple of say 2. So it will be 6 cross 64, one will be 6 cross 64 decoder, another will be similarly 8 cross 256 decoder. So the correct answer will be D. Again I am repeating, a decoder with n select line will have 2 to the power of 9 output. Okay, how many outputs are required here? For steps 50, and for instruction 129. Now, then obviously both are not power of 2, because it has to be a power of 2. So the nearest will be 64 and 256. So it will be 2 to the power 6 and 2 to the power of 8. So it will be a 6 cross 64 decoder and a 8 cross 256 decoder respectively. Understood? If you have any doubt, you can ask regarding this. Okay, so let's go to the last question. So which of the following statement is or are true for microcontrol unit? So option A is my control signals are generated by circuits like encoder or decoder, encoder decoder. Option B is it's flexible for modification, and option C is it's used in CISC architecture. So if you have gone through the theory, the correct answer will be B and C. So in micro program CU control signals are stored in memory and loaded sequentially based on instruction. So it is also available for modification since it is stored in the memory, and it's basically a CISC architecture. So it doesn't require encoder or decoder kind of stuff because it is stored in the memory, all the control signals. It has not to be generated again and again. So option B and C are correct. So if you have any doubt, you can ask. This is the last question. I will then repeat whichever question you have any doubt. Question 1. Okay, I will show question 1. So the question 1 says, if the instruction of a machine is 64-bit long, which has a addressable memory, which has a byte addressable memory, then to point to the next instruction by the PC, what should be the PC value should be indicated by part. So if you look in the memory, it is said it is byte addressable, and the size of instruction is 64-bit. So what is 64-bit? 8 byte. So to point to the next instruction, it has to be increased by the value 64, right? Like to point to the next instruction. So PC will be PC plus 8 byte, since it is byte addressable. If it is bit addressable, we will add it PC plus 64, but it is given byte addressable, so it will be 8. Now it's clear. Yeah. Okay, so any more question I will show, you need to, like, you have any doubt any of this question? Oh, last problem. Okay. Yeah. Okay, course one again. Okay, 1 minute. 1 minute. I will show you one again. So the question one. So basically, it is byte addressable. Byte addressable means each word, yeah, is addressable using a byte. Byte is 8-bit. So here it is said that the instruction is 64-bit long. So if it is 64-bit long, so it is suppose 0 to 63 is the first address location. So from where the second instruction will be executed, 64. 0 to 63 is first instruction. Then the second instruction will be 64 to 127. So in that case, so the PC address basically will get incremented from 0 to 64. So if since it is byte addressable, how byte addressable means, we will write the 64 as 8. So the PC value will be PC plus 8. Now it is clear. Okay, so last problem. 4, it is different. It is then 32-bit. It is, 4 will be 16. Everyone will be different. Some, it is not some textbook. It is uh, corresponding to the problem that has been given. It is in some, suppose the instruction is 32-bit long, so then it will be 6, right? So if it is 16, yes, so if it is 32, it will be 4 byte. So in that case it will be 4. So it all depends on the size of the instruction, it is not constant. Okay, so this is a question number 10 is basically a theory question. So if you have gone through the lectures micro program control unit, you will be knowing this. So control signal units are stored in memory and loaded sequentially based off instruction. So in the in hard corresponding to hardware control unit, where it is always the control units are generated using hardware circuits, it is not the same here in microprogram unit. So in microprogram unit, the control signal are stored in the memory and are loaded sequentially based on instructions. So as a result, encoder decoder stuffs are not required. So option A is wrong. Option B is correct because it is flexible for modification. You just like if it was a hardware control circuit, so the circuit is always already present, the decoder or encoder. So you cannot change the modify the circuit, but you can modify the programs always. So it is flexible for modification, and also it is used in CISC architecture, this microprogram control unit. So option B and C are correct. Clear? Can you explain load instruction LW? Oh, okay. 1 minute. LW dollar is 100. So if you have attended the previous solution, like previous like live sessions videos, you can watch also. I have done problems regarding this. LW dollar is 1. So it means here we are loading a value or loading something from memory to this register S1. Also it is said there is a register S2. It contains some value, suppose 1000. Make it bigger. Suppose S2 is a register, it contains suppose some value 2000. What it means here is load uh, the value from this location. So suppose this one is 2000 and 2100. So this means this value will be loaded to this one. So this is called base index instruction, like logic or something, like base index addressing mode, base index addressing mode. So here this is the base register, this is the 100 that is being added to this, and from this location the value gets stored in this register. Clear? You can go and check like my previous recorded sessions. You will find some nice problems we have done regarding this kind of things. It will help you get accustomed to this kind of things more easily. Okay, so if you have any more doubt, you can ask, or else I will end the session. Okay, okay, thank you. Let's we will again meet next week, same time, Tuesday, 6 p.m. We'll again solve some questions for week 5. Thank you.